Hello everyone, my name is Sleigh, and today I'm going to be explaining the topic of the tragedy of commons and resource management for EC 238 Environmental Economics. I'll start with a quick introduction on our topic, followed by some theory, then relating it back to real-world applications, and finally some solutions using economic tools. So let's get right into it. Imagine you and your neighbors share a lake filled with fish. No one owns the lake, and anyone can fish there as much as they like. Over time, you notice fewer fish, but everyone keeps fishing anyway. Eventually, the fish population collapses. That is the tragedy of commons, overuse of a shared resource due to individual incentives conflicting with the most socially beneficial solution. What I just described was a common pool resource, the lake, a type of resource that is accessible to a group of people, but where it's difficult or costly to exclude people from using it, and where one person's use reduces the resources available to others. In this video, we'll explore how common pool resources like fisheries and groundwater get depleted using economic theory to understand why it happens and what we can do to fix it. To understand the tragedy of commons, we first need to look at some basic economic theory. This is a classic example of market failure caused by the absence of property rights. When no one owns a resource, like the pond I just described, everyone has the right to use it, but no one is responsible for conserving it. That creates an incentive to extract as much as possible before someone else does. Another issue is the lack of pricing signals. Since people don't pay the true social cost of using the resource, they tend to overuse it. Their individual marginal cost is lower than the social marginal cost, creating a negative externality, a cost pushed onto others or future users that is not reflected in today's decision. So this is a high-level diagram of resource stock over time, which kind of demonstrates the concept of this theory. The red curve shows what happens under open access conditions without regulation or ownership. Users will over-extract. The resource stock declines rapidly and falls below the sustainable threshold, which is the dashed blue line here on the graph, which is the minimum level required for the resource to naturally regenerate. Once this red line dips below the blue, the system can no longer recover and you're on the path to long-term resource collapse. On the other hand, the green curve shows what happens under regulated use or private ownership. When there are rules in place like quotas or permits or defined rights, users are more likely to internalize the long-term costs. This leads to slower extraction and the resource stabilizes above the threshold. The key takeaway here is, without intervention, common resources are overused and eventually exhausted. But when we apply the right economic tools, like assigning property rights or regulation, we can prevent collapse and manage the resource sustainably over time. So I mentioned before that the reason we have this tragedy of commons problem is because basically people act in their own self-interest. So let's break down what this means. There are two ways to look at it. First, there's the profit motive. If a producer can cut down trees or catch fish to sell a profit, they'll keep doing it. And second, if one producer chooses to stop for sustainability reasons, others will not. Those others will continue to extract resources, and the one who held back will lose out. So rational producers feel forced to keep exploiting the resource to avoid being left behind. This is why common access resources are so vulnerable. Each person's self-interest leads to overuse, and that leads to resource depletion. So let's visualize this. Let's take a look at the common access resource diagram to see how this plays out. Suppose we're analyzing the market for lumber, and this is our common access resource diagram for it. Under free market conditions, we will consider the marginal private cost curve, and then the marginal social cost curve, which is much higher because of the long-term environmental damage. Marginal private benefit equals marginal social benefit, which equals demand because the externality is on the production side, not the consumption side. The market outcome is where the marginal private cost curve meets the demand curve at Q1 with price P1, but this is an overproduction point. The socially optimal level of production is where the marginal social cost curve meets the demand curve at Q star with price P star. This shows us two major issues. One, too much lumber is being produced, which leads to deforestation and resource depletion. And the final product that is being produced is priced too low, which encourages overconsumption, making the problem worse. This results in a dead weight welfare loss, which I've highlighted on the graph here. This area represents the economic loss caused by the misallocation of resources. So, to sum up, common access resources lead to unsustainable production, negative externalities, and in serious cases, market failure. That is the tragedy of commons and a key challenge in environmental economics. So, now let's look at two real-world examples that show how the tragedy of commons plays out in practice. One involves fisheries and the other involves groundwater. So, the first case I'll talk about is fisheries. In many coastal regions, fish populations are considered a common access resource. There's no strict ownership or regulation over the ocean, and therefore no ownership or regulation over who can fish and how much. This leads to what's called open access fishing, where anyone can fish freely, so everyone races to catch as much as possible, as fast as possible. This ties back into what I was saying earlier about self-interest, and in this case, there's a pretty clear profit motive. An example of an ecosystem failure can be seen in the cod fishery collapse out in Atlantic Canada. For decades, the waters were overfished, and despite warning signs, there was no coordinated effort to conserve the stock. So, in the early 1990s, the population collapsed entirely, leading to lost jobs, lost income, and a devastated ecosystem that still fully hasn't recovered. Another case that you might have heard of is groundwater or drought problems, specifically in regions like the California Valley. Farmers pump groundwater to irrigate their crops, but there are few restrictions since the resource is shared and unregulated. So everyone pumps more than they need to avoid being left out or not having enough, and the result of this is that aquifers in California dry up. This causes people to dig wells deeper, which costs more and therefore drops the water table for everyone, which means water becomes more inaccessible. These examples highlight a key issue. When there's no exclusion, it doesn't make sense for any one individual to conserve. The short-term incentive is to take as much as possible before someone else does, even if that means destroying the resource in the long run. So far we've seen how open access to common resources like fisheries and groundwater can lead to overuse and eventual collapse, but economies and governments also give us the tools to correct these failures and guide us towards a more sustainable outcome. The first mechanism is regulation. This is when the government imposes rules like fishing quotas, seasonal bans, or no fish zones, in the fishing example, that directly limit how much of a resource can be used and when. These policies can be really effective in protecting ecosystems, but like most things, there are some drawbacks to these policies, which is why they're not always in place. Enforcement can be expensive for governments, and rigid rules and changes might not always go over well. The second approach is to establish property rights or tradable permits, so basically monetizing a common access resource. One successful example of this is the use of individual transferable quotas, and these are used in all kinds of cases in Canada on fisheries and dairy farmers and egg farmers. Under this system, farmers are given a share of their total allowable catch, and those shares can be bought or sold. This aligns individual incentives with the collective good, because when you own a quota, you have a long-term reason to preserve your resources because your future profits depend on it. In both cases, we're solving the same core issue, the externality. Without intervention, private users ignore the cost that they impose on others, but when we create ownership or enforce limits, we internalize that externality, bringing the resource use much closer to the socially efficient level that economists aim for. So, to wrap things up, the tragedy of commons shows us how individual incentives, when left unchecked, can lead to the overuse and eventual collapse of natural shared resources. Through economic theory, we understand that the root of the problem lies in the lack of property rights and pricing signals, but we also saw that there are real solutions, regulations like quotas and bans, and market-based tools like permits. Ultimately, environmental economics isn't just about understanding how these problems occur, it's about designing smart, sustainable policies to manage our resources better. So, thank you so much for listening. I hope this helped clarify both the problem of the tragedy of commons and resource management and the path forward.